Hello and welcome to this webinar about integrated power management in buildings. My name is Claudio and I am the marketing manager for DesigoCC, our flagship solution, building management solution here at Siemens. And I will be your host today. Joining me in the studio is Urs von Gunten, product manager and DesigoCC expert, who will lead the first part of this session. For the second part, we have Sebastian Winkelmann, who is joining us virtually and will cover the second part of this session. Before we start, I would like to do a little bit of housekeeping. So now you should see the first question coming up in the poll. And this is short feedback if you can see us and hear us. So no question, no answers coming in yet. Perfect. I see some yeses coming in. Beautiful. All right. Now, if you have any questions during this session, please submit them in the chat. We have a question function, and we'll address as many of your questions as we can during the live Q&A at the end. If we should not be able to do so, we'll of course answer them in writing afterwards. Now, in previous sessions of this webinar series, we've discussed the semiconductors industry's crucial role in the digital world, contributing over 574 billion to the global tech economy. So as you can see here on this symbolic slide, that a lot of other industries are somewhat codependent on semiconductor producers. However, this industry also faces significant energy consumption challenges, using over 230 terawatt hours annually. This is comparable to Australia's yearly power consumption. Now, this webinar series addresses these challenges by presenting a dedicated solution in each session. While today's session focuses on the semiconductor industry, we also want to recognize that the same insights may also apply to other energy-intensive sectors and industries out there. We'll explore how integrated building and energy management systems enhance energy efficiency in facilities like administrative offices and small to medium-sized data centers, for example. To illustrate the importance of a BMS, consider driving a car. Ideally, you're in possession of a license. You have a dashboard that tells you exactly how fast you're going, how much fuel you have left, and how many kilometers you've done so far. And you have a steering wheel with which you can control the car. Similarly, operating a building without a BMS is kind of like driving without these critical tools. Now, if applied systematically, a building management system has the potential to reduce building and energy consumption by up to 25%. Yet, only 10% of buildings currently use them. So there's a lot of room for improvement, as we can see. And with this, I want to hand over to our first topic expert of today, Urs. So let's get started and see how the Desigo CC is applied in buildings.
Thank you, Claudio. And also hello from my side. I'm, as mentioned, the Desigo CC, a PM of this management station. And I would like to introduce you in the next few minutes, if you want, to the BMS called the Desigo CC. BMS stands for Building Management Systems, and basically it's a piece of software to monitor and control equipments, technical equipments in a building. Whether it's heating, cooling, fire safety, access control, video, intrusion, power, whatever is there, or even a control, or let's say monitoring of lift situations, this can be monitored and controlled by a BMS. And here we have our flagship, the Desigo CC BMS. I would like to introduce you. First, there are some slides, and then I will do a small live demo. So, one of the major, let's say, strengths of the Desigo CC is that this software is a piece of software for all disciplines in a building, as I mentioned before. Whether it's HVAC, whether it's fire, whether it's security, whether it's power, whatever is there in a building can be monitored and controlled via one big screen. This has a lot of advantages for users, for customers. They save money, costs. It's easier to have the training, so it's one training for all disciplines. There are a lot of advantages having one piece of software for multiple disciplines. Obviously, if we look at the market and how it is received, not always you start with the holistic view where you say, I want to have everything in my BMS. Maybe I start with the security part or with the lightning part or with the HVAC part. And over time, I can add more disciplines. So that's what we see quite frequently in the market, that you start somewhere with one discipline and over time add more and more to end up with a so-called total integrated solution where all the disciplines are on one screen. So having all disciplines on one screen makes a lot of sense because you get a much easier overview about the situation in the building. But what you get on top is another interesting, maybe we could call it side effect. Let's say if you have multiple disciplines, you can also create clever interactions between the disciplines. Let's say we have a fire in this room, but the fire safety guy who needs to look at the system is at a completely different place, but there is a camera in this room. And so I can then organize the CC in a way that if a detector in this room triggers, like a fire safety detector or an intrusion detector or whatever kind of detector is triggers, the system knows which cameras is focused on this trigger, on this sensor, and you get immediately the right picture and video stream. I will show you this afterwards live. Now, another strength of the CC is obviously if you want to monitor and control everything in a building, I mean, technical equipment in a building, you need to be very open. So we have all the major protocols, whether it's BACnet, Modbus, OPC, OPC-UA, IEC, SNMP. We have all the relevant protocols in the building integrated in the CC so we can talk and monitor to those devices. So basically, that's a very important point, that it's very open. And we go here even a step further about openness. Let's say you have a very specific thing you want to integrate. There are a lot of possibilities, but one possibility is that you use our REST API, basically, to control, to add functionality to CC using the northbound layer. It's a web service interface where you can add additional functionality on top of the CC. And then we have the southbound layer. It's also a REST API. If you have a specific device with a very specific protocol, which we do at the moment not support, we have a software development kit, and you can create your own driver and access so that we have the data points in the CC, even if they are coming from a quite special subsystem. So the openness is key. And we believe the CC is one of the most open products in the BMS world on the market. Good. Now let's prove and show you our demo. I would like to switch now to my demo installation. And basically what you see here is, I would say, the CC in its smallest version. Let's make it a little bit bigger. Basically you have here the so-called alarm view summary at the end. You see there are different categories of alarm, very important on the left side, less important on the right side. And if there are, you get a color, it's blinking, so you get information immediately about the situation of the pending problems in your building. Okay, so let's make it a little bit bigger here. And I would like to explain one of the big things about this management station is that we have very different users. Users with very, let's say, small interest in the CC, they need to be guided some way, and other experts which want to know each and every detail. So we work therefore with profiles and per discipline and also per skills of the users. So basically in the simplest version, you just have a layout like we have it here, where you say basically I have just my graphic, and I use all the navigation in the graphic, so I never leave the graphic, and I can do different things here. But for example, I can go have a look to my ventilation system, and I see immediately the situation of my ventilation system. This is a schematic overview, but you see the symbols are animated. So basically I see the air is coming from the left, is going into this room. There's a ventilator blowing in the air in this room at the temperature of 20 degrees and something, and here it's blowing out. I see the ventilator here as well. But what I see also, it looks like cooling is needed. Therefore, this pump is running, and I see this pump is running at a certain percentage here. So I get a good overview about the situation of this air handling unit looking to this schematic thing element. Okay. So what I now want to say is I can have a look at these elements here. I can also let's say like this. I can make it here smaller. And we have different layouts, as I explained. This is the simplest one, where we just have the graphic and its navigation purpose. But if you want the whole thing, all the informations, you go just to the most complex view, where we have on the left side the tree, to select the elements you are interested in. I can then select in this primary plant here, for example, the temperature here, select this element, and I get then on my related items, everything which is related to this data point, which can be another graphic, which can be a trend, which can be a report. And I go now to this trend here, the manual supply air, and I get immediately now the trend of this temperature. So I have a very good overview and a full-blown Desigo CC now with all its potential. Okay, good. So let's close this again. So maybe this is the one use case where you say, I want to see something and maybe I want to change something. But most of the time, I'm more as a user in a reactive position. You will get maybe alarm that something is not okay and you have to deal with this situation. So let's do this. I create now a fire. Let's go back to our simpler overview with just a graphic here. No, I still need the element here on the left side. Let's go now to a scenario, and I would like to trigger a fire, obviously a virtual fire. So I put this fire detector into the status of fire. And now you see the reaction of the system. Basically, we get now in the situation of a so-called assisted event treatment. Let's put yourself in the shoes of an operator. If a fire alarm is coming, there are two options. Maybe it's a real fire or it's a technical problem, so it's not a real fire, but there is a certain stress situation. And for these stress situations, we have the so-called assisted event treatment, that because if I'm in a stress situation, I would like to be guided. So you can define the steps, the guide steps according to the alarms. And you say, first, okay, if there is a fire alarm, there is some documentation to be read. Okay, done. Next point is, I want to see where it is. Okay, let's move now to the source detector. Okay, I see there in this room, the detector is triggered. And as the next thing, I would like to see, and here comes now these clever interactions. If there is a camera nearby this sensor, I get automatically the correct stream. So I don't have to think, oh, I have 200 cameras and maybe camera 177 is the right one. No, you don't have to think about this. It is connected because it's multidiscipline. Everything knows each other elements and we can interact between those disciplines. Okay, I've seen this as well. Here, another interesting part, mainly also used in Germany. You can say, I want to know, as a fire brigade, how do I enter into this system? How do I enter into this building? And here you get the PDF according to the sensor, which has been triggered. And in the PDF, you see this is the entry. I have to go in. Then I move one floor up, and I'm here in this area where we have seen the trigger. Okay, I've done this as well. This works, so the fire brigades are informed how to enter. And maybe here as a last point, I would like to make sure that I'm not distributing the smoke using my ventilation system. Okay, then here again, I have now my ventilation system, and if you look carefully, it's in emergency off. And if I look here even at the ventilators, they are all off. So obviously this has been done automatically. This is more a verification that this really works. And if it didn't work, I can still manipulate it from here. Okay, I have done this well as well. The good thing about this situation is that basically, afterwards in the logbook, you can see that the person has reacted within a minute or so, did the steps in the right order, everything has been done carefully according to the rules, and it can be proved even that it has been done in a good way. Okay, so this was about this part, about when you are triggered. Then let's go now back to our overview. Okay, I put it back here to normal. And let's go back here to our building. And as I mentioned here, and let's go to our basic view, just the graphic. And I can now also have a look at the power. What are the electrical elements in my building? And I see basically, okay, looks like everything is green here. They are all connected. They all have power. This guy here has no power. Obviously, it's a generator. We don't need the generator now because we have power. If there is no power, the generator would switch, and we should see it green here as well. You can then even see here, I have some meters. And I see, yes, we have our 230 volts. That's fine, and it's live. Okay, that's good. And I can now, having a look at the volts is maybe interesting, but more interesting is what about the energy consumption? And here we can also have a look at the energy consumption at the end. How does this look? We go now to the module which is called power management, power or energy management. I go now to this application here. It's called power management. I have my building, and I can go, for example, to my cooling plant, and I see now the situation, the meter in this cooling plant. I see the total active power, I see the total apparent power, and I see the factor. I see some consumptions which I compare to last month, to last year. I see current trends. So there are dashboards, and I can very quickly switch from one dashboard to another one. So this is really very comfortable and very fast also engineered, that you have a good overview about the energy or other consumption. It could also be water, gas, power, whatever consumption it is. We have here this module called power management, which my colleague Sebastian will have a closer look afterwards. Good. So now I showed you one client which we have. We have now also a newer client. It's just a web-based client, and I would like to show you this client as well here quickly. So we have this web-based client. Basically, I open my browser, typing the right URL, and I'm there. I'm logging in now to exactly the same server, and basically here you get, if I go here now to the very same view, I get exactly the same element which you have seen before. So I could also navigate here, just using the graphic, or having the tree here as well. So it looks very similar, but now it's controlled by a browser. And there are also some advantages. So it's our new user interface. First of all, you can use it on a tablet. And with version 8, you will be able to use it from a smartphone. And then you get additional benefits here. For example, if I look at this building, there are elements which can be used here. Let's go to our logical view. I go again to my building. And now we have here a nice overview about all the rooms in this building and all the primary plans. And maybe here I have a building with more rooms. So that's a very easy introduction. So because if I have a floor plan with all my rooms, that's fine. But maybe sometimes I would like to have a quick overview with all my rooms in a building, independent where they are, just in this building. I can then also filter. I can say I want to see every room which has more than, let's say, 22 degrees, and I get immediately an overview. Obviously, everything is vector-based, so I can make it fast. So there are a lot of ways to use the advantages of a browser interface. And then I can go back to my building. The same, we have not only the rooms, we have also the plans. If I don't want to go via the graphics, I want to have an overview, I can go again via these tiles. I get in the tiles the most important information about the name. This here is a primary plant called air handling unit. There seems to be a current temperature, blow-in temperature of 20.8 degree. There is a commanding value, a set point of 21. It's on, and it's controlled by a scheduler. So I get all the basic information just with one little tile. And if I want to go from here deeper into the things, I can click on these buttons here and say, show me the plant. And you know now where you are, exactly at the same plant which I showed you before. I can go back. And I can also see that basically it's not only the plant I can navigate to, I can navigate from here also to the scheduler, which we saw is controlled by the scheduler. I see today we have Wednesday. I can go to the edit here and start changing the elements here so that I say before it's off, now it's on. So I can control the scheduler here, and I can go back again to my tiles without saving anything, and I'm back here again. So I think I could show you much more, but I think I wanted just to give you a short overview about the modern user interface, easy to use, all disciplines on one screen, the Sigo CC. Good. Then let's have now a look and continue on our slides about some more details about energy management and energy saving. There are different regulatories. It's a big landscape. Worldwide, we have different regulations available. I would like to focus now in this place now on the European laws, the EPBD and the EED, and dig a little bit deeper into those. They are very relevant for Europe, because at the end of the day, the EU wants to be the first climate neutral continent by 2050. And we have rolling goals so that we save energy using this directive EPD and EED, which I just want to explain now in more detail. Now let's have first a look. The EPBD stands for Energy Performance of Building Directive. So here it's more, I would say, about buildings. Heating, cooling, buildings. What energy do we talk here about? Maybe we talk here about megawatt hours. It's quite a lot, but it's megawatt hours. On the other side, we have industries like this bakery, where this oven really uses a lot of energy. And here in this EED, which is relevant for the very high consumer of energy, the EED is relevant. And here we want to reduce with the EED the energy consumption by 11.7% in 2030 compared to 2020. And as you know, all these directives are on the level of European Union, and each and every country has its own, let's say, derived out of these general things, laws. And in Germany, for example, we have the energy directive in Germany is called Energieeffizienzgesetz. And what you see, the relevant things here is this is valid, this law, for energy consumption of gigawatt hours. So if you exceed the consumption of 7.5 gigawatt hours as a company, as an owner of this company or this business, you have to fulfill this directive. And one of the major elements of this directive is that you use an energy management system, EMS. And I can tell you, our BMS, the Sigo CC, is also an EMS, and it's even according to ISO 50001. So with the Sigo CC, you can fulfill the EED, basically by measuring the right things and then making the right actions out of these measurings. Then we go now, this is the high consumer, I would say, the gigawatt hours. Now let's go back to heating and cooling, which is more, let's say, the megawatt hours. Also here we have some relevant triggers. If a building has an installed power for heating and cooling equipment of 290 kilowatt and more, it must have a building automation system. So it cannot be controlled manually. And with this building automation system, it must be possible to monitor, log, analysis, the energy and other usages as well. So basically what this means, each and every building needs to install meters, measure the elements, the consumption, and have a software which is able to visualize the measured things, like you can do it with the Zesigo CC Power Manager, as I just showed before. So here, the relevant law in Germany is called GEG, Gebäudeenergiegesetz. Good. So I would like to hand back to Claudio for the next session.
Yes, thank you. And now we have Sebastian, who is joining us virtually and will kind of do a little deep dive into power management, as we've seen before in your teaser demo. And he will also cover the topic of power quality as well, which is kind of our digression topic of today. So Sebastian, if you're in the call, please take the stage, and I hand over the microphone to you.
Thank you, Claudio. Thank you, Urs. Welcome, everybody. Nice having you here. And let's go into the first slide already. So it's about the seamless integration of power management in building automation and control systems. So what we saw now from Urs in the demo, I think gives a very first good insight how to connect all those disciplines together. We focused, or the demo was like with the fire and surveillance system, but all this connection is of course also then available within the energy management system. So we can collect energy data from measurement devices, like our Siemens measurement devices, also power quality devices. Of course, other vendors are also supported as per our openness concept that was mentioned, and even circuit breakers to get the status information, but also the condition monitoring capability and the condition management capability is then all part of the system. So we get all those information inside via different protocols, for example, 1+TCP or the IEC 61850 protocol. And we are able with this to visualize it in dashboards for you, for the operators at the end of the day, to reduce, to first of all have the transparency to see where is my energy going in various dashboards or reports, and also then being able to analyze and live an energy management process as for example with the ISO 50001, to start the process and the activities to reduce energy consumption, and therefore CO2 emission, and ultimately of course also cost. So how can we then enhance the building performance with this power integration? So as said, we monitor and identify the problems in order then to fix them. So this will increase our productivity and the comfort of the building. We increase the transparency. So gaining the insight of the consumers, gaining insight of my switchgear, of my electrical distribution, of the condition of my breakers, of the health of the electrical power supply will first of all give a better transparency and also avoid outages and failures or unplanned maintenance activities. So this will help keeping uptime, keeping your lights on, keeping the facility up and running. This of course will help you to reduce operation costs. So first of all, cutting the electricity costs, but also for other energy, other media, and also help to reduce electrical power peaks, for example. So you analyze your consumption, you analyze your load durations, and you optimize the behavior of your system, of your building, of your consumers, like in a ISO 50001 energy management process, where then the actual development and replanning of the production cycles or your system activity can be done based on this information. And then, of course, this will help you to analyze and understand existing behaviors in your system in order to prevent problems coming up again and prevent future damages. This energy saving, then overall, why is this needed? This is then only the one place. Of course, we have the regulations, reducing CO2 emissions, and this is but just the first step. So electricity is not only available or not available, but it also comes in different qualities. So I don't know if all of you are aware of this topic. So power quality is a thing where when you have different levels of voltage supply from your electricity supplier, so from outside, from the grid, this can come in different qualities, so to say, but also your own behavior within the factory or within the building can have an influence on the power quality and on how your power behaves. And due to the fact that we have increasing prosumers, so meaning buildings that produce their own energy and consume at the same time, the complete energy landscape is changing. It's becoming more and more deregulated. You see more and more converters in the system that changes, and this will result ultimately in a need for monitoring this power quality to ensure and to make sure that you get the right thing, first of all, from the grid, from your energy and power supplier, but also that you don't, by accident, introduce problems within your own facility. And this is the topic of power quality that we want to have a further look into it. And what are the most typical reasons then for failures? Just at the next slide, we can see the topics like voltage deviation, harmonics, voltage sags and swells, but also transients that can come up in a system, especially in the semiconductor industry where you have very fine processes. This might result in differences or difficulties and problems at the end of the day during your production site or during your production process. So you would see, for example, voltage deviation where the voltage is higher or lower over a certain time. This can lead to system shutdowns due to an undervoltage trip. So the protection devices, the breakers, actually do what they have to do in such a case. But the deviation is over a longer time. Or you would have overheating and the thermal load in the system that also results in higher energy consumption because you produce heat that you don't need. So it's a waste at the end of the day, and also would potentially damage your equipment, so decreasing the efficiency of the electric equipment. And then, of course, shortened the service life of the equipment due to this increased thermal loads. Then the harmonics, for example, they can have or have an influence on sensitive electronic components, processing units and such things, where this might lead to failures, to downtimes, to the devices being reset, or that engines and transformers turn to overheat because of those harmonics that are being introduced into your system by your electrical power distribution. And certain breakers or fuses would be able to, or would not work in the correct way, might malfunction. Voltage sags and swells, on the other hand, are short duration voltage sags, so they go down, or swells where the voltage is increased for a short time. This could result then in a data loss or a storage loss and data errors on your databases, on IT equipment. One that is very obvious to, or can be observed, and even as when the lights, they would flicker. That's also how this event is called. So you would be really able to visualize it, visually recognize this failure. Or the life of engines can be shortened due to those events, sags and swells. And transients, which are very short-term high peaks, could be introduced due to flashes outside of the, but also can be introduced due to some internal problems in your or challenges in inverters or such. So they could result then again in hardware damage, data loss, or a damaged power supply units. And all those things can happen actually, and will result, of course, in a bad power quality. So your energy supplier, of course, has to ensure that they deliver you power in a certain way, in a certain quality. But at the same time, you can have a electrical distribution within your campus that also introduces such events. So what you now can do to find out that you might have a problem, or you know already you have a problem and you want to locate it. So we have the technical solution in the combination of the power manager, the COCC power manager, what we just saw from Urs, and a combination of our SciChem power quality instruments, power quality recorders, that are able to quickly recognize those events and visualize them then together with the power monitoring and power quality advisor functionality in the COCC. So it's a combination of hardware and software that helps to record those events, store those events. Also, the devices are certified and classified that you can see, does the event come from outside or inside of your grid, and that you then, of course, can also argue with your energy provider and can talk to them that you have proof that the power quality was given to you is not in the way that it was agreed upon, or they help you to locate the source of the fault if it comes from downstream, meaning from internal of your system. You be able to find the source and switch it off or do some measures to prevent it. So as said, those devices in combination with our software, which is part of this COCC, will help you to find, identify, and analyze those events. Then one additional view. So what is now the big benefit having this in one system or in a separate system? So both is possible with the COCC, with Power Manager. So you can have, as was said, all those subsystems combined in one system, to have it on one single pane of glass at the end of the day, to have it on one screen to define it. But you can also even start alone with this power monitoring functionality and then scale up to the different applications if you need to. So both ways are possible depending on your actual needs. So an EMS, including condition monitoring, including power quality, but also the combined BMS, that is what is available for you. Connecting breakers, connecting power quality instruments, connecting energy monitoring devices, and of course relevant for semiconductor industry, but not only, also critical infrastructures might need this, data centers, buildings in general. And yeah, now I want to give you a little bit detailed view on what we can show and visualize and what kind of reports we have available within this Power Quality Advisor functionality. So as said, that's the combination of those devices, Q100, Q200 out of our SciChem portfolio. They are power quality recorders, also known as power quality instruments. They gather the data quickly, and then it's being transferred to the power manager systems, being visualized on those kind of dashboards according to an EN50-160 standard, where you can see in the already browser-based client this card views to identify, okay, what kind of events are there in my system, in my duration, last 7 days, last month, be able to detect those voltage variations. You see there I had over time deviations from the standard. So the standard allows to go up and down from my nominal voltage a little bit. You can analyze those harmonic variations that we mentioned, where it is depending on the the order of the harmonic, that you can go above those values. You see, does it come from downstream? Comes it from upstream of the measurement point? You can really drill down into the individual events, even to have a look, do I have sags and swells according to this ITIC curve or CBIMA curve, also SEMI-F 47 visualization. It's possible to see, okay, is the sag or swell, does it have an influence on my IT equipment, on my production? And drill down in the actual waveform even to really see the trigger event, to see what was the reason for this event, and then being able to derive measures out of this. Again, the Flex client or the client here has this very good filter opportunity that you have your complete list of events and being able to really dig into the details and find out, and also afterwards being able to analyze them again if you changed the system behavior. We condense this information in the area views and then the system views to have a very simple dashboard overview of your complete campus. So the screen that we saw previously is on a single device. And now this here is an area overview where you then have this card overview of multiple devices and have the easy transparency across your complete campus like now. So that's the power quality kind of visualization for your complete site. Now we are going back into this existing or into the standard client. There you would define a report, select all the measurement points, and then you get a automatic report also for this, again, according to this EN 5160 standard, which can be sent via email or stored in a location automatically, that you have a continuous reporting functionality to visualize all your data for power quality and store it and have it archived. You see, okay, over time, I had a continuous improvement, or everything is fine as it should be. So with those words, I think I can head back into the studio. Thanks for your attention, and I think we go to the Q&A in the next minute.
Great, thank you so much, Sebastian, for your introduction to power quality. And now we can start with the Q&A. I see there's not too many questions yet in the chat, but maybe they will start to come in. Maybe let's start with the first question to you, Sebastian. So we have a couple of questions that are frequently asked by customers, for example. And so what kind of reports can the ZegoCC provide, the ZegoCC Power Manager provides to check up on the energy consumption in the building?
Mm-hmm. So we have a variety of predefined report templates. You get like your top 10 consumption, a Sankey report where you see all how the energy is distributed. And this would also how I would start my energy management process. So I would look at where does my energy go. So I have my measurement concept set up, and I look where does my energy management, where does my energy flow, and then I see what are my critical consumers. Maybe what are the biggest ones. Maybe this is my production side, and this has to run in the first place, and I don't want to touch it. And I have several side processes that I can optimize easier. So I would start maybe with those. Then pick this and look at the load duration. So we have a template for load duration as well, where you then see, okay, do I have a relatively straight load over time, or do I have a certain short time over the day, over the last 24 hours or over the last months, that has a short duration but a high peak? And this is then where I can start digging deeper into the system to actually look when these peaks happen and do my energy management to talk to the people, to look at my production site or get the data also from the ZegoCC environment, look at my campus. So what happened actually there? What at this point in time was all on, was needed, and can this be optimized? So this would be the first steps. Then of course we have additional reports for energy analysis. We have this EN 5160 report template that we saw. We have a balancing report sheet to see, okay, what comes from outside, what goes, or what's like an external source, how it's used. So various reports are available here. Also, you can also define your own templates according to your needs.
Question to you, Sebastian, because I think we are in this power manager space anyway. So what kind of meters can actually be connected and monitored with the Desigo CC?
So as of today, well, of course, all our Siemens energy meters from our pack portfolio, all our breakers can be connected and monitored easily. As per our openness concept, we of course also support third-party devices with the Modbus protocol. It's always recommended and simpler for you at the end of the day to have Siemens devices. But if there is in your brownfield application 1 or 2 meters not from Siemens, that's also okay to connect. Then in the very next steps, we will also be able to connect to the BACnet meters to have the visualization for other energy media like air, gas, heating, cooling information to bring all this in the same dashboard.
All right. And when it comes to power quality meters, can we also integrate third-party devices or only our CCAM devices?
That's the CCAM devices for today. So we do this CCAM Q100 to 200 for the evaluation of power quality.
All right. And now we have a little bit more of a specific question. So if in a factory, let's say Siemens has an EMS and Power Manager is used already, how is this then integrated in the Desigo CC? Can the licenses be reused? Maybe that's a question even for you, Urs.
Yes, and I think that's exactly the idea. If you want to combine, you can do though. And there is a migration path, or let's say a clear path how to add more disciplines. If you have now a Power Manager just for Power Manager, Central Power Manager, you can extend it to the Desigo CC with additional possibilities to control and monitor other disciplines. Yes, this is possible.
Yep. And I see now another question coming in, and maybe that's another question for you, Sebastian. Can we also integrate let's say pull in reports from other sources into Power Manager, for example, from the energy provider?
Well, I'm not sure if I get the question correctly.
Maybe if I rephrase, so is it possible through the Desigo CC or Power Manager to integrate some report from third parties, for example, like energy providers?
So, I mean, adding the documents as such is, of course, possible. Having the different templates, you can create your own templates. Adding the data that you got from your energy supplier manually is currently not possible, I have to admit. But this is a topic that we know of, yeah.
Yeah. If I may add here a word, there is, let's say,
yes,
an additional option which come now with the newest version 8. So there will be a possibility to connect the Desigo CC to show its openness even to Microsoft's Power BI. And there in this context, you could say, I can merge in Power BI elements which are coming from the Power Manager, from the CC, or from a completely different source, and have it in one dashboard in Power BI.
Right. And
this is a part of version 8. Huh?
Yeah, that is coming.
It's coming very soon.
I see another question coming in about HVAC integration. So can, for example, a Daikin HVAC be integrated into the Desigo CC? And what are the required devices to achieve this integration?
This is absolutely possible. And then basically we talk about Daikin, we know very well, and we know this is possible, it's no problem. It's all about protocols. So what protocol are supported on the other side? I would say in building automation, it's mainly BACnet the main protocol. So if we integrate a Honeywell BACnet or a BACnet controller from Daikin, no topic. It's the same behavior like a Siemens BACnet controller, but it's not only BACnet. We can also go via Modbus TCP, OPC UA. There are a lot of different ways to integrate existing systems and to monitor it and control it from the SIGO CC.
All right. And now I have another question regarding power quality, and that is Power Quality Advisor also is it able to also give a recommendation on what to do during a power quality event, for example?
Well, you get with the dashboard a first overview on what is the root cause of the event. So we don't give or tell the customers with the PQ Advisor module directly what to do, because we would need to have a certain information about the actual behavior of the system and what is actually behind. So giving a very generic information is not this helpful. And not having the details, how does the complete system and the site is operated, doesn't allow at the moment in the Power Quality Advisor to give such a recommendation. On the other hand, there are additional services available from Siemens that can exactly do this. So they can connect on top of the data that is there in Power Manager, and you then would upload basically the information from Power Manager to our service department that then would be in contact directly with you and understands how your electrical system is designed, and they then on the other hand can give you real recommendations and offer you a even better value.
All right. And since we talked about EPBD and regulations, I have another question regarding power quality. So is there any specific policy or regulation around power quality?
Well, it is the EN 5160 that is the standard coming from the grid. So if you're an energy supplier, you have to follow this. On the internal side, basically, it's not directly. So following this EN 5160 dashboards and recommendations is definitely a good starting point, yes. And there is individual ones in the different countries or areas of this world.
All right. And then maybe we have a question about reporting again. So here I'm not too sure who could be able to answer this, and I'm not really sure to what type of report this refers to, but is DESIGO CC also able to support ITIC reports via its own UI?
Well, this is the thing that we also saw shortly in the demo. So we have the ITIC curve in our EN 5160 dashboard in the Power Quality Advisor, and it's also part of the EN 5160 reporting template. So you would see that you deviate according to the ITIC curve, or even the SEMI F47 curve. So that's there.
All right. So I guess we are almost out of time. I just want to mention again that we have provided you with the slides in the handout section, so on the top right corner, and there you should be able to find all the material. We also have provided you with a checklist for these new EPBD directives, which gives you kind of an indication of what the directive is all about and what it requests from the market, basically. Yeah, I think this is it. We're almost out of time. So thank you very much for attending this webinar. I hope we could be able to deliver you some nice insights. And if you have an immediate need or an opportunity, please don't hesitate to contact us. We start the last poll for today. And we leave it open, so please feel free to also, rewatch the recording and just fill it out, and then we can get into contact if we can. All right. So thank you very much also to the speakers, Urs, Sebastian. It was very nice having you here as well, giving us these nice demos and the introduction to power quality. So, yeah.